Hi, I'm Yazid Sandurwan. So today is the first video series for building services. Before moving on, I would like to mention you about our channel description video. Please watch that video. If you watch that video, you can realize what we are going to put in this channel and what is the actual flow of this video. So moving on to this video series, this is actually one of the building services video series, and also this is regarding the fans. So actually this is fan video series. In this video series we would like to discuss about basic types of fans, actually the introduction and the basic mechanism of them, and fans performance, fan curves, fan loss, fan stalling, and fan performance due to some characteristic, and also some practical applications. Okay, those are the things we are going to discuss regarding the fans and in the fan video series, and also about fan impellers, types of impellers and the characteristic due to the impeller types. Those are the things we are going to discuss. So this will be the first video of the fan video series, and in this video we are going to discuss the basic types of fans and also their mechanism. Okay, so before moving on to the fans, I would like to mention about fans, blowers and compressors, and what is the difference between those three types. Actually, if we consider a compressor, at the delivery end, their energy is mostly in the form of pressure, but less in velocity. Okay, when they deliver some air, at the delivery end, the form of energy is mostly in the form of pressure, less in velocity, compared to fans and blowers. Okay, but if we consider fans and blowers, at the delivery end, their energy, the energy of the air is mostly in the form of velocity, less in pressure. Then the difference between blowers and the fans have much less pressure compared to the blowers. So their velocity is high compared to the blowers. In blowers, they have more pressure at the delivery end than fans, and they have less velocity than fans. Okay, so if we take specific ratio means delivery pressure over suction pressure. So compared to the suction pressure, when fan sucks some air and they do some work and deliver the air. This is the basic mechanism. So if they suck some pressure, suck some air, it has some pressure, and also if they deliver some air, that delivery should have some pressure. So specific ratio means what is the delivery pressure compared to the suction pressure. Okay, for the fans it should be up to 1.11. So compared to the suction pressure, it is not much developed at the delivery end. It is just 0.11. Okay, we in the blowers it is 1.1 and to 1.2, between 1.11 and 1.2. Compressors more than 1.2. Compared to the suction end, he creates more than 1.2 pressure at the delivery end, more than 1.2 times pressure at the delivery end. Okay. So this is the basic fundamental theory which we can differentiate fans, blowers and compressors. Okay. So if you consider the fans, okay, now you know what are fans. There are two types, axial and centrifugal fans. Okay, so you know what are axial fans. In your day-to-day life, you mostly deal with axial fans. Day-to-day life means in your house you may have axial fan for the tables fans or stand fans, ceiling fans comes under axial fan category. In axial fans, they are called axial because, so in this fan, this is the axis, okay, so air is sucked along with the axis, parallel to the axis, and also air is delivered parallel to the axis. That is why it is called axial fan. Okay, so let's see how air is sucked and delivered parallel to the axis. Okay, so air is obtained along a path like this. Okay, along a path like this. Air is sucked like this. Okay, here let's say they have 1 meter cube flow per 1 second. Okay, in this area air flow is 1 meter cube per 1 second. That flow rate, we call that flow rate or air flow. That flow rate should be equal here also. Flow rate here equal to flow rate here. But here this diameter is now decreased. Actually this is an imaginary line, okay, this is not an actual line. Air is coming like that. Okay, so in this imaginary duct the diameter is decreasing. Because of that, to deliver same air flow, air have to speed up. Okay, air is now increasing its velocity. Why? Because he have to, air has to deliver same flow rate through a narrow duct. Okay, through a narrow duct. To deliver same flow rate, air has to speed his velocity. Okay, he has to increase his velocity. Okay, according to the Bernoulli formula, if the velocity is increased, pressure is now decreasing. Okay, you know that velocity increased, pressure decreased. Okay, so if I draw the velocity, so this is the fan blades. Okay, if I draw the velocity, velocity will be increasing like this. Velocity is increasing like this due to this scenario. Then what about the pressure? Now we know pressure is decreasing. Pressure is decreasing like this. Pressure is decreasing. This is pressure. This is velocity. Okay. Now the pressure is decreasing. Then when the air contact with these blades, blades are moving. Okay. They have rotational speed, so that means they are doing some work on the air, on air molecules. They are doing some work on air molecules. What is happening is, when something work on something, their energy is increasing. As an example, let's take, if I take a ball and raise it like this, I am doing some work on this ball, what happens is this ball increases its energy as potential energy. When we are doing some work on something, their energy is now increasing. So now our fan blades are doing some work on the air molecules. Because of that, in that air, the energy is now increased. At the beginning, from here to here, same energy should be there, like this. Here energy should be equal to here energy here. So constant energy from here to here. But because of this work by the fan, the energy of the air is now increased, like this. Energy is now increased. Can you see that? Okay. Energy is now increased, like this. Let's say okay, now energy is increased. Here the input energy, and after the fan energy is increased now. Okay, but the thing is, if I draw the velocity across the fan, velocity is not increasing rapidly after the fan. It is gradually increasing, but there is a rapid increase in the energy. Here you can see, I cannot show you a very large gap here. Okay, let's say this is the initial energy and this is the energy after the fan. Okay, there is a gap, huge gap, but here velocity does not show a rapid increase in velocity. You know, our total energy has two components. Total energy has two components. One is energy due to velocity. Okay, if something moves, they have some velocity. Due to that velocity, we have kinetic energy. That is due to its velocity. We call that dynamic pressure. Dynamic pressure of the air. Then other one is, let's take a container with some air molecules. That air molecule pushes the wall like this, and the pressure that wall feels would be static pressure. Static pressure. So total pressure or the total energy are consisted of these two types, static pressure and dynamic pressure. Altogether, this is the total pressure or the total energy. Okay, so there is dynamic pressure due to the motion, and there is static pressure which does not move in a direction. There is no any directional flow in here. Okay, so the total pressure, they have two components, dynamic pressure, static pressure. So the energy, total energy has two components, dynamic pressure and the static pressure. So here total energy has increased rapidly after the fan blades, but one component of the total energy has not increased rapidly. What has increased rapidly is the pressure. Pressure now increased up to here. Okay, and see, velocity is now increasing. We have constant energy, but velocity increasing. But what should be the decreasing component? That is static pressure. So although static pressure has rapidly increased up to here, but it gradually decreasing like this, because velocity is gradually increasing. This should be gradually decreased. This is gradually increasing. That is why total energy is a constant. But after the blades, there's a huge gap between the energy. So energy has increased. That means that is why this static pressure has increased. Okay, because velocity has not increased after the blades. So before the blades, velocity is this much, and after the blades, velocity is this much. So it hasn't changed very much, but total energy has gone up to a certain level. Because of that, static pressure has increased. Okay, now let's see here. At the far behind the fan, we have pressure, atmospheric pressure, P0, and also at this end we have P0. Okay, that means here we have P0 energy, that is atmospheric pressure, that means normal pressure, and also here we have atmospheric pressure. And also you can notice the pressure behind the fan has decreased to P1, and after the fan it is increased to P2. Okay, so P1 here, P2 here. Definitely P1 is lower than the P2. P1 is lower than the P2, and also P2 is higher than P0. Sorry, P1 is lower than P0, and also P2 is higher than P2. Sorry, P0. Okay, so you can clearly see that there is an pressure difference. You know, for an air to move, there should be a pressure difference. Okay, from higher pressure to lower pressure, air is moving. So where is the higher pressure now? Here is the higher pressure, here is the lower pressure. So from the higher pressure to lower pressure, air is moving. And also after the fan, what is the higher pressure? P2. P2 highest pressure, P0 is the lower pressure. So from higher pressure region to lower pressure region, air is moving. That is why we have a flow like this through an axial fan. Okay, so that is the mechanism. Okay, basic mechanism. When we come to the centrifugal fan, this is the centrifugal fan. Okay, centri means center, and fugue means away from the center. The centrifugal means away from the center. So there is centrifugal force. You know, if you are travel in a car and when the car takes a turn, we feel a force away from the turn. If a car moving or take a turn like this, we feel a force away from the turn. Okay, so that is centrifugal force. Although there is no such an actual force like acting on like this, but we feel that we feel such a force. Okay, we feel such force that our body is moving away from the center of this circle. Okay, center of the circle, away from the center of the circle. So that force is called centrifugal force. Okay, that force is only felt by anything which in this frame. Okay, I'm not going to explain it here because we don't need that here, but you have to keep in mind there is a centrifugal force. So that is the force that centrifugal fans are using. Okay, so actually for the centrifugal fans, air is coming at this direction. Okay, in this plane air is coming, and the output delivery will be in this plane, this direction or this direction, however the direction, it should be in this plane, and air is coming in this plane. So definitely there is an 90-degree difference. Here it comes in this plane and it deliver in this plane. Okay, when air comes this way and it goes like this. So there is a 90-degree difference between these two planes. Okay, so in centrifugal fans, air is turned by 90 degree, but in axial fan they take air flow like this and deliver like this, no turn. But here there is a turn in the airflow compared to inflow and the outflow. So that turn is due to centrifugal force. That force I mentioned earlier. Okay, so in this casing, inside this casing there's something like this. We call these things impellers. Okay, impellers. In fans we have blades. You know, these are blades. Like these blades we have impellers. Those are blades. Okay, so we call impellers. Okay, then it is rotating. When they are rotating, what happens is, if I draw another view, if I look at this from here, I can see something like this. And it is rotating in this way. Okay, so actually air is sucked at this direction for this area. Okay, so air is sucked for this area, then it is rotating. Okay, then it is rotating. Because of that motion they have centrifugal force. Because of that air is moving to this area. Okay, air is moving to this area. When air is moving to this area, that means now air in this area is less. If air is less, that means pressure is now decreasing in this area, in the middle part. Now we have less number of air molecules. Because of that, pressure is decreasing. Compared to the outside, it has a lower pressure. Always from high pressure to low pressure, air is moving. Because of that, from the outside, air is moving, or air is moving to this area, or we can call air is sucked to this area. Why? Because when air comes to this area, due to the rotational speed, they have centrifugal force and air molecules come to this area. Because of that, less number of air molecules here. Because of that, less pressure compared to the outside. Because of that, air is sucked. Okay, so that is how air is sucked to this impeller. Then due to this rotation, okay, due to this rotation, circular motion, they have centrifugal force. Because of that, they are going to move away from this disc. Okay, so as I told you earlier, if we are moving in a circle like this, this is the center of the circle, we feel a force away from the circle, we call that centrifugal force. Centrifugal force. Okay, so likewise, these air molecule should move away from the disk, but these air molecule do not move in this direction. Actually, they are moving in a direction like this. I will tell you the reason for this in the next video when we are doing velocity diagram for the impellers. Okay, so they are moving like this because due to the centrifugal force they feel a force away from the center. Because of that, they will leave this disc. They will leave this disc like this, and we are building a casing to collect that air like this. So actually this is this one. Okay, this is the casing, this is the casing here. Okay, so this is the mechanism for centrifugal fan. Due to that centrifugal force, air is released from this disc. When air comes in this direction, due to the centrifugal force, air is moving this disc in this plane, and all the air will be moved in high velocities from this outlet. Okay, so that is how airflow is generated in centrifugal fan. Air comes in this direction and moves in this direction, this or this or this, however the direction is, it should be in this plane, and air comes in this plane. There is 90-degree difference, so it is due to this centrifugal force. Okay, so that is the mechanism of centrifugal fans. Then we can move to the major differences between axial fan and centrifugal fans. Centrifugal fans, so axial fan, actually the pressure development is actually low compared to the centrifugal fan. In centrifugal fan, they develop high pressure development compared to the axial fan. Okay, at the beginning I told you, compared to the compressors, fan does not create or produce much pressure compared to the compressors. But here we compare axial fan and centrifugal fan. If we compare axial and centrifugal fan create much pressure than axial fan. Air flow. That means per 1 second how much of air in cubic meters, or unit can be anything. That is the air flow. Air flow is actually high than the centrifugal fan. In centrifugal fan, air flow is a bit less than axial fan. Okay. How about the installation cost? Installation cost is lower than centrifugal fan. Why? There are several components for a centrifugal fan. There should be a casing, and if there is a duct system, so installation cost is high. And also power input. Power input is also low in centrifugal axial fan. Centrifugal fans, power input is high compared to the axial fan. So those are the major differences if we compare axial fan and centrifugal fan. Okay, so these are the basic types, axial and centrifugal type, and there's another type. Okay, we call that mixed airflow fan. They have both this mechanism partially. So if this is the fan and if you consider this is the airflow, likewise in centrifugal fan this move like this, and likewise in axial fan it moves parallel to the axis. So something happens like this in mixed airflow fan, but I do not explain it deeply here because I just want to focus the basic types of fans, that is axial fan and centrifugal fan. So in this video we discuss about the differences between fans, blowers and compressors. Okay, then when we come to the fans, there are two different types, axial fans and centrifugal fans. We discuss the differences between axial fans and centrifugal fans, and also the basic mechanism of axial fan and centrifugal fan. So in next video we are going to discuss what are the categories of axial fan and what are the categories of centrifugal fan due to impeller types, and what are the differences or the characteristic or what are the performance differences of the centrifugal fans due to the impeller types. Okay, so we will meet in the next video.